So welcome back to Lesson 8 in the Boot Camp Math. This series is mainly for older learners, high school and above, who just need a refresher course in computation skills because you've forgotten a lot of that and now you need it for, high school math, for ACT, ASVAB. Math is math. I don't care what letters you give to it. So this is Lesson 8. We're going to talk about exponents, but before we talk about exponents, let's talk about the difference between a coefficient and an exponent. What's a coefficient? Well, it looks like 3x. And an exponent would be x to the third. So what do those mean? A lot of things in math were developed as a shorthand because the more times you have to write something, the more likely you are to make a mistake. So in math, anytime we can shorten something, we try to do that. That's why scientific notation was invented. But anyway, what does a coefficient mean? Well, it means add that number that many times. So 3x means x plus x plus x. All right? So what does an exponent mean? Well, it means multiply. So the difference between a coefficient and an exponent is that a coefficient is for addition and an exponent is for multiplication. And that's why, as we go along, you're going to hear me say this over and over. When you add, exponents never change. If you add something together, two things together, and they have exponents, the exponent never changes. The only thing that can change an exponent is when you multiply it times that base again, okay? All right, now let's look at some basic rules, and I've kind of done these. Usually you see these with X's and Y's or M's and N's instead of numbers, but I think it's a little bit easier to get the hang of it. And I'm going to kind of prove these to you. That makes it a little bit easier to just memorize the rule and go with it, okay? It just saves you some time. So if you have two bases with two exponents, what that actually means is, what is x squared? Well, it's x times x. And what is x to the third? Well, that's x times x times x. So what do you have here? You have x to the fifth. That's why it's a shortcut if you have two bases with two exponents to just add the exponents, okay? All right, now what about one base with two exponents? What you actually have here, and that's why I want to expand this out, I want you to understand these rules. X to the second to the third, well, let's go the outside one first. That exponent tells you how many times to multiply that base. So what I actually have is x squared times x squared times x squared, right? Now let's expand some more. What is x to the second power? Well, that's x times x. And this one is x times x. And this one is x times x. Now what do you have? You have x to the 1, 2, 3, 4, 5, 6th power. So you could shortcut this and say, well, that's x to the 2 times 3. So now see the difference between these two problems. Two bases, two exponents, you add the exponents. One base with two exponents, you multiply the exponents, okay? Now let's look at division. What happens when you have something with an exponent on the top? If I expand this out, I've got 5 x's up here. What do I have down here? 3 x's. All right, every time you have x over x, that's equal to 1. And when you multiply 1 times 1 times 1, nothing changes. That's why, so what do you have left? You have on the top x to the second power. Shortcut would be to say 5 minus 3 because the overlap is just going to cancel each other out. That's why you can subtract. Now for this one, my larger number was on the top. What happens if your larger number's on the bottom? Well, that's where your remainder is going to go. For this one, I would have 3 x's on the top and 5 on the bottom. So they still all cancel out. Now what do you have left? Well, what do you have up here? 1 times 1 times 1 which is 1. You still have the 1 in the numerator, okay? You still had a 1 in the denominator up here. It's just you don't have to put x squared over 1. That's just, when you have a 1 in the denominator, you can leave it off because you're dividing by 1. Well, if you have a 1 in the numerator, you can't leave it off. So the answer here would be 1 over x squared, okay? What I do is I just always subtract the small number from the large one, and then I put my answer where the largest one is. And you'll see this as we work through the practice ones, okay? The last rule, what about negative exponents? Negative exponents tell you that that base is unhappy where it is. It needs to go to the other side of the fraction bar. When you look at this, you say, well, I don't see a fraction bar. Actually, there is. Actually, this is over 1. So in order to make that exponent positive, what you have to do is move it to the bottom. So you would have 1 times x. It makes that positive. What do you have left up here? A 1. Now, you don't need that one because 1 times x squared is just x squared. So x to the negative 2 power simplifies to 1 over x squared. All right, what if it's in the bottom? Same thing. It's unhappy wherever it is. So it has to go to the other side. So what I do here is I would move it to the top, multiply it times 1. That's going to be x squared. Now, is it over 1? Yeah. But like I was saying, you don't have to put the 1 when it's in the denominator. Okay, a few other things of importance. If you have anything raised to the 0 power, this is equal to 1. You don't figure this out. This is a construct that was invented. In fact, there are mathematicians who will argue this with you, but it is a rule. It is a fact right now, and that's what we're going with. If you have 2,531 xyz all to the 0 power, that's equal to 1. Okay, 0 power, the base, is equal to 1. Now you have to be sure that it's just the base. For example, if I had 2 x y to the 0, like this one, this exponent only affects that base. So only this becomes 1, so you still have 2x. Okay, so be careful with that, but as we go through the examples, that's going to become a little more clear. Okay, let's look at these two possible cases. You've got 2x to the third plus 5x to the third. So what do you have? Well, if you've got 2 of these and then you've got 5 of these and you add them all together, you know what you have? You have 8x to the thirds. Remember, that's what I was telling you. The only thing that can change an exponent is multiplication. So 2x to the third plus 5x to the third, you've just got a whole bunch of x to the thirds. Now, let me come over here. If this had been 2x to the third times 5x to the third, then you would do 2 times 5 is 10. Oops, yeah. And x to the third, you would add 3 plus 3 and get x to the 6th. So if they were multiplied, it would increase your exponent. But since they are added, it does not. Now when you are adding, if the exponents don't match, you cannot combine those terms. Okay? This is like apples and oranges, just because they have a different exponent, so you cannot add those together. Okay, let's just look at some examples. So what we need to notice is the specifics in this, and math is very specific. Notice where the parentheses are and where the exponent is. In this one, I have a negative number inside parentheses and I have an exponent outside the parentheses. And exponent's power is very limited. It is limited just to the base. What is the base? The base is just what it's touching. So for this one, it's touching the parentheses, so the whole thing is the base. So what this actually means is negative x times negative x. So what's a negative times a negative? It's a positive squared. And you can conclude from this, If your exponent is inside the parentheses, if your negative sign is inside the parentheses and your exponent is an even number, it always changes it to a positive, okay? Now let's look at this one. This one, it's still a negative x squared, but this time the x is in parentheses but not the negative. So what this actually means is negative x times x. So what you actually have is negative x squared. The exponent can only affect what's right below it, and since this is not included in the parentheses, then it doesn't count. If I just, and like my answer here, when you have this, that does not change to a positive x because there are no parentheses, okay? All right, let's look at example 2a. Now this one, look at what's inside the parentheses because that is what is squared. So this is going to be 5x times 5x. 5 times 5 is 25, x squared. So that's going to be your answer. Now look at this one. The 5 is not in the parentheses, so the exponent cannot affect it. So your answer here is 5x squared, okay? And remember, these rules were created to standardize answers. One of the biggest problems we had in math was people getting different answers, so that's why we came up with all these nitpicky rules. It's to make you get the same answer that everybody else does. So it's not whether you can figure it out, it's do you know the rule, okay? All right, on B, this is something I catch people with all the time, x plus 5 squared. Well, I can tell you what it is not. It is not x squared plus 25, okay? It is not that. When you see a binomial to a second power or a set of parentheses to a second power, it doesn't matter if it's a binomial or not, that means multiply the whole set of parentheses together. So what you'd have to do here is x plus 5 times x plus 5. And I know a lot of you are probably recalling the FOIL and the distributing. We're going to get into that in a little while. But for now, I just want you to understand this is not x squared plus 25. All right, now we talked about the negative exponent. The negative exponent tells you that that base is on the wrong side of the fraction bar. It wants to move. Well, here we have a whole fraction raised to a negative exponent. So expanded version, what you have is this. They're both unhappy, so they're both going to flip. So now it's going to be y over x, and you don't have... An exponent of 1, positive 1, is one of those invisible numbers. It's always there, but you don't have to put it, okay? So what you can conclude from this is if you have a fraction raised to a negative exponent and the whole fraction is in parentheses, you can just flip the fraction and then that makes your exponent positive. Okay, now let's look at example 4. And this is where we get into the area of you might work this differently. Because, like I said, you can only work with 2 numbers at a time. The 2 you choose to focus on will let you get at it a different direction, but you're still going to get the same answer. I tend to just start at the beginning and plow my way through. So let's see what can I simplify here. And before we get started, I see a negative exponent. And I know that means I kind of need fraction form. So what I do in my head, you don't have to write it, put it over 1, okay? So when I need to make that positive, it has a place to go. Now, there's nothing that's going to, well, there actually is. What can I combine the 4 with? I can multiply it times 3, and what does that give me? 12, okay? Now, what is x to the 0 power? It's just 1, and 12 times 1 is 12, so I don't have to worry about it anymore. Okay. Now on the y to the negative 4, y to the 1, you can do one of 2 things. You can put the 4 on the bottom and then reduce, or you can reduce now and move it to the bottom. So if I look at it now, I can combine these 2. What exponent does this actually have? It has a positive 1, correct? Now what is negative 4 plus 1? Well, that's negative 3, right? So at this point, this is what I have. Now, how do I make that exponent positive? Because it's not considered simplest form, and that's where we're going. We want to get everything in what we call simplest form, and simplest form has rules, and one of the rules is no negative exponents. So if I'm told to put this in simplest form, all I need to do is make that exponent positive, and the way you do that is by moving it to the other side of the fraction bar. Wherever it is, it's got to go to the other side, okay? So lowest terms would be 12 over y to the third. All right, now let's go for example 5, and there's a lot to unpack here. A lot of different ways we could simplify this. Let me rewrite that so that it looks the same. Now, the first thing I see a lot of things first. Let's just kind of walk through this. I like to have everything simplified on the top and the bottom first. So 2xy squared is fine. But down here I have two y's, and I could combine those, so I'm not going to touch the 4x to the fourth yet. But what is y to the negative 3 times y to the negative 2? If you're multiplying, you add exponents, and negative 3 plus negative 2 is negative 5. Okay, and I keep making two different kind of y's, and it's kind of hard to, okay. All right, so now let's see what all we can simplify. Well, what I would do, all right, what's 2 over 4? What goes into both of those? 2 does. So you got 1 left up here and 2 on the bottom. All right, let's look at your x's. X and x to the fourth, remember we said you could just subtract, and what I do is I subtract the small one from the larger. So that's going to be 4 minus 1, which is 3, and it's going to go where the largest one is, okay? Now, what I have left at this point is y to the second and 2x to the third, y to the fifth. And that's a negative 5. So we've got to do something here. We've got to combine the y to the second and the y to the fifth, and one of the easier ways to look at it, it's kind of a cop-out. I know a lot of people just say, okay, let me subtract those, but when one of your exponents is negative, it gets a little confusing, but watch this. That negative 5 is unhappy, so why don't I just move it to the top and let it be happy at positive 5. Here's 2x to the third. Now, what is y to the second times y to the fifth? Y to the seventh. And 2x to the third is perfectly happy. So, you could have said, I'm going to subtract, 2 minus 5, and since it's minus a negative, that would have been plus. However you want to do that, okay? So now, that's all your examples. I want you to pause and you work the problems on your worksheet, see which ones you get right, and then you can come back if there's any that you did not get correct or didn't quite understand. I'm going to work through every single one, but you learn more when you try the problem yourself first, and if you make a mistake, we go back and we find out why you messed up, okay? So you try them first and then come back. Okay, so let's go over your practice problems now. And your directions told you to simplify each expression, to leave no negative exponents, and to order your variables in alphabetical order where possible. And the reason you want to put your variables in alphabetical order is that makes it easier to see what needs to be combined. Like if you've got 3xy plus 2yx, your brain might not pick up on that. You can actually combine that because multiplication is commutative. 2 times 3 is the same as 3 times 2. If they're all multiplied together, you just put them in the best order possible. Okay, so here I have 3x to the third times 2x to the fourth y to the third. Now remember, when you're multiplying bases, you add the exponents, and the exponents don't have to match for multiplication. Now for addition, they do. So here I'm going to multiply 3 times 2, that'll give me 6. X to the third times x to the fourth, I'm going to add and get x to the seventh, and then I have that y to the third. So check it, it's simplified, there are no negative exponents, and my letters are in alphabetical order. Alright, number 2. 4x y to the fourth times x to the fourth y squared. Now I don't have another number to multiply 4 by, so I'm just going to go ahead and put that in my answer. Now when I multiply x times x to the fourth, what exponent does this x actually have? It's actually got a 1. So when I add the exponents, that's going to be 1 plus 4. So I have x to the 5th. Then y to the 4th plus y to the 2nd, that's going to be y to the 6th. And that's your final answer. Okay, let's look at number 3. I've got x to the 0, y squared times y, x to the negative 3. And even though, you know, there's a multiplication sign in here, whenever you have a monomial or a polynomial multiplied times another polynomial, they're all multiplied together. So you just mix and match them. First of all, x to the 0 power, what is anything to the 0 power? It's 1, and 1 times anything is just that thing. So we can just, we're not, you know, just not paying attention to it, but it's 1, and 1 times anything is just that thing. Now, y to the 2nd times y. Remember, this actually has an exponent of 1, so that's going to be y to the 3rd. So that got rid of these two. Now, you can do this in 2 steps or 1. You see this x to the negative 3, it's unhappy. It doesn't match anything else. That's all I'm left with. So it's got to go to the denominator. And you can make it a separate step, or you can just stick it down there and make your exponent positive. There's nothing else to combine it with, so it was just getting it positive. All right, let's look at number 4. First, multiply those constants together. 3 times 4 is 12. Now look, I have a y to the 4th and an x to the 2nd. They don't match, so I can't combine them. There's nothing else to combine them with, so they're just going to come over here, but I need to put them in alphabetical order. So let's put x squared first and y to the 4th next. Okay? All right, now for number 5, I have this 2y to the 3rd in parentheses, and then I have the exponent outside. Now remember, that actually means you're going to multiply 2y to the 3rd times 2y to the 3rd. You can write it out if you need to, or you're kind of distributing it inside the parentheses. So what is 2 to the 2nd power? Well, 2 times itself is 4. Now when you multiply y to the 3rd to the 2nd, you've got one base, 2 exponents. What was your rule for that one? It was multiply the exponent. So you're going to have 3 times 2, y to the 6th. All right, now let's go to number 6. First of all, go to the outside. I'm looking at this, and I'm going to cube or raise to the 3rd power everything in here. Now, since the negative is inside the parentheses, it can be affected by that. A negative cubed is negative times negative times negative. Let me write this. If you've got negative times negative times negative, well, negative times negative is positive, and then positive times negative is negative. That's why I told you, if you have a negative raised to an odd exponent, it's going to remain negative because everything cancels out except for that last one, and it's left over, so it makes the whole thing negative. Now you have x to the 2nd to the 3rd. You have one base with 2 exponents. So that's what your answer is going to look like, negative x to the 6th. Okay, for number 7, there's nothing to combine. There's no constants that can be multiplied. The only thing wrong with this expression, the only reason it is not in simplest form, is that negative exponent. And why do you make a negative exponent positive? You move it to the opposite side of the fraction bar. Where's your fraction bar? Well, this is actually over 1, okay? So if I move it, that's going to leave x to the 2nd on the top. The y is going to go to the bottom and be positive, okay? All right, now we look at this. 5x to the 3rd plus 2x to the 3rd. Remember, when you add, your base and your exponents have to match. And then all you're doing is you're adding coefficients. So this is going to be 7x to the 3rd power, okay? Now we look at number 9, 2x squared y plus 3xy squared. Well, x squared y is not the same thing as xy squared. So there's actually nothing you can do for this. Your simplest form is just like it is. So you can either just write NA or write it down just like it was. You cannot combine those because x squared y is not the same as xy squared. All right, now here's number 10. We're going to multiply everything. So let's break it down into 2 at the time. 3 times 3 is 9. All right, x squared times x squared. When you multiply 2 bases, 2 exponents, you add those exponents. So that's 4. Y to the third, y to the second. When you multiply 2 bases, 2 exponents, you add the exponents. So you've got 9x to the fourth, y to the fifth. Okay, let's look at number 11. This is the big one. We've got x to the third, y to the third, 2y squared over 2x to the negative 2, y squared, all raised to the negative 2. Different schools of thought. Some people like to start on the inside and simplify all that first. Personally, I like to start on the outside and get rid of that negative just because it bugs me. But whatever you want to do. So this is what I do. First, because that's a negative exponent, it's just going to flip what's inside and nothing's going to change. For example, this negative 2, when I flip it, this is still going to be negative. Okay, the only thing the flip is going to do is change this to a positive. So let's do that. I'm going to take what's on the bottom, so that's going to be 2x to the negative 2, y to the second, over x to the third, y to the third, 2y squared. Now it's all still going to be squared. Okay, so now what I'm going to do is, let's simplify what's inside now. So what I would do here, there's nothing, the 2's divide out, cancel out, however you want to say that. So let's take care of those. Now, x to the negative 2, what actually happens to an x to the negative 2 to make it positive? Well, it has to come down here, okay? And then x to the third times x to the second is x to the fifth, okay? So we took care of those. All right, now I have a y to the second up here. Let me just go ahead and take care of that. Down here I have y to the third, y to the second. What do you do when you have 2 bases, 2 exponents? Y to the fifth. Okay, I'm not near about done. I'm doing this little bits at a time. I know a lot of y'all like to do a lot of mental math, but I try to just do little bits and pieces because I don't want to lose anybody, okay? All right, now I'm still on the inside. There's still some simplifying I can do on the inside before I try to square anything, and that is y to the second over y to the fifth, okay? You've got a fraction, so you're going to subtract exponents. Now what I do is I say I'm going to subtract the small one from the large one. That x to the fifth is not going to move and it's not going to change, so I'm going to copy it down and I'm done with it. So I can say 5 minus 2 is 3. That's going to be y to the third. So where does it go? It goes where your largest exponent was. So it's going to stay down here. If you remember, you know, I showed you how they cancel out. Well, if you had 2 y's up here and 5 y's down here, what's going to happen? The 2 y's are going to cancel out, and what do you have left? You have 3 y's left on the bottom, okay? Since there's nothing up here, I'm going to put a 1 as a placeholder, and now I have to square everything in that set of parentheses. So 1 squared is 1. X to the fifth squared, 1 base, 2 exponents, you multiply, so that's going to be x to the 10th. 1 base, 2 exponents, y to the 6th, okay? So all of this simplified down to 1 over x to the 10th, y to the 6th. Okay, let's look at number 12. And once again, you've got all these components. There's no rule about which you have to do first. So you just, you know, you do whatever catches your attention first. And I'll tell you, the biggest thing that catches my attention right here is y x to the third to the 0 power. Because I know that anything to the 0 power is equal to 1. And I know that all of this times 1 is just this. So that's just 1. That got rid of all that. In fact, let me just come over here because it's going to look so much simpler when I take that out of it. Now let's see. Now I have y to the 4th over y to the 4th, which is also 1. So I don't have to worry about it. It divided out, it canceled out. So what you actually have at this point is you have x to the 2nd over 2x to the negative 4th. Now what about that x to the negative 4th? It's got to go on top, right? And you probably don't even need an extra step for this, but I'm going to do it in an extra step. When you move it to the top, that exponent becomes positive. Now, what is x to the 2nd times x to the 4th? You add your exponents, so that's x to the 6th over 2. Okay, let's look at number 13 and see what all we can clean up here. First of all, I see that x to the 0 power. That's just 1, so I'm going to mark it out. Okay. I cannot do anything about this negative exponent until I get this out of the parentheses. So I'll tell you what I'm going to do on this one. First, I'm going to distribute that 3 in here. Now remember, you're going to wind up multiplying this times both of the exponents, because technically what you have is x to the 3rd to the 3rd and y to the negative 1 to the 3rd, 1 base to 2 exponents. Now the y to the 2nd, I'm not going to do anything with it right now. So x to the 3rd to the 3rd is x to the 9th, and y to the negative 1 to the 3rd is negative 3. And then down here I just have a y, okay? And a little unorthodox here, but watch this. I see this long 1y down here, and I see a y squared up here. What is y squared over y? This actually has an exponent of 1, so if you did 2 minus 1, you would get y to the 1st power, or just y, and it's going to go on top where the biggest exponent is. So these two things cancel out, and that becomes just a y, and that way I don't even have a fraction right now. So I've got x to the 9th, y to the negative 3, okay? I can combine these two. This actually has an exponent of 1. When you multiply them, you add the exponents. So what is 1 plus negative 3? Negative 2, x to the 9th. And then last but not least, I can't have a negative exponent and be in simplest form, so that y has to go back down to the bottom and be y squared down here, x to the 9th. And like I'm saying, you don't have to do your steps in the same order that I do. Just whichever numbers hit you that you want to simplify at that point, 2 at a time, or even 1 at a time. Just get it simplified. Okay, so for number 14, let's see what all we can do here. I'm going to go ahead and draw a fraction bar, because 5 over 4 is not going to reduce down. Now, x over x, they divide out, they're equal to 1, and 5/4 times 1 is 5/4, so I don't need to worry about it. Okay, now y to the 5th over y to the 4th. I can subtract my exponents. 5 minus 4 is equal to 1, so I've got y to the 1st power, and that's going to go wherever the largest exponent was, which is on top. So it's just y. You don't have to put the 1, so 5y over 4. Okay? Now for number 15, these are added. So before I can combine with addition, you have to take care of exponents or multiplication. So what I'm going to do is I'm going to distribute this into the parentheses. Now 3x to the 4th is not going to change right now. 2 to the 2nd power is 4. And x to the 2nd is x to the 4th. Now you have variable portions that match, so you can combine. 3x to the 4th plus 4x to the 4th is 7x to the 4th. Remember, when you add, exponents never change. All right here, 4x to the negative 1. You know that that negative exponent means that base is in the wrong place. It wants to go to the bottom. But you also need to remember that can only affect the base right below it. So it doesn't affect the 4. The 4 is going to stay on top. The x is going to go to the bottom, and that exponent becomes a positive 1, which you don't have to put. So you're just going to put 4 over x. Okay? Now, number 17, we have a fraction 1 over 2x to the negative 2. And it's kind of the same thing here. All right, nothing's going to affect that 2, but this negative exponent belongs to the x only. So you're going to have to move the x up to the top, and that exponent becomes positive. Now, when you multiply 1 times that, it's just that thing. So you don't have to have the 1 anymore. But your 2 will remain on the bottom. So that's what your final answer is going to look like right there. Okay. Number 18. Well, whenever you have a fraction in parentheses, the exponent that's outside the parentheses affects everything. So you don't have to write it out. You can. But this is going to be 1 squared, which is 1, and 3 squared, which is 9. Okay, let's look at number 19, 6x over y to the negative 2. So what's wrong with it? Well, it has a negative exponent, so what do you do to change a negative exponent to positive? You move it to the opposite side. Wherever it is, it has to go to the other side. So this is going to have to go to the top. So now you've got 6x y to the second. Now what's on the bottom? Well, it's actually a 1, but you don't have to have that. You don't have to put the 1 in the denominator. All right, and that's all you can do, okay? So that one wasn't hard at all. All right, our last one, number 20, we have these 2 sets of parentheses. All right, first of all, the 2 sets of parentheses are multiplied, and everything inside the sets of parentheses is multiplied. So that just kind of equalizes out. You know, everything is equal here. They're just all multiplied together. So we're going to commute them probably in our head, rearrange it, so that we can combine certain things. For example, start with your constants, your numbers. 3 times 2 is what? 6. All right, now, x to the second times x to the negative 2. Let's think about that just a second. Do I really need to flip it? You could. If you flip that, you're going to get x to the second over x to the second, which is what? 1. And you don't have to have it. If you do exponent minus exponent, what's 2 minus 2? X to the 0, which I told you was 1. So either way you want to look at it, these two things are 1, and when you multiply them by 6, you just get 6, okay? So the last thing to simplify is y to the third and y to the negative 1. 2 bases, 2 exponents, so you're going to add. When you add 3 plus negative 1, you get positive 2. So your simplified form is 6y squared, okay? And we will be moving into lesson 9 next. I'm excited. That's going to be distributive property and FOIL method, I think. So I will see you right back here for lesson 9.